do friction last just because it's the one that can get the most complicated. Although there are sometimes, I think, clear cut which ways it would go, but not always. All right, so give me a force and a direction. Acting.
Down onto the ground from one.
All right, so work on the preposition here.
Onto the ground.
Well, I'm drawing the arrow on the ground.
Nope, you're gonna draw it on the box.
All right, so which way is it acting on the box?
Down.
Yeah, okay. I figured that's what you meant, but it's all part of the vocabulary. They come in pairs. I'm using one.
Up from the ground to the box.
On.
On. I'm gonna get there.
Spoiler, same with two. All right, so weight is done.
And the same for the pulley in the ground.
Pulley and ground, they're part of the same thing.
Yeah. So there's no weight force between the two?
Right.
Okay.
Pulley, because I drew them connected like this, we treat them as one thing.
Okay.
Would make you feel better if instead of a pulley there, I put it just like a lump of dirt. Okay. The lump of dirt happens to look kind of like a lollipop. Or,
Pulley shaped map.
No, it was the first.
anyway. Another pair.
Normal force on one from the ground.
Going which way?
Up. No, this way. Well,
Perpendicular to surface. One of these days, I'm gonna find out that students have actually been taught that normal means perpendicular, as opposed to a word that you don't see until you get to Calc 3.
It's the same for box two, right?
Same spirit, yeah. This way though. And that's a 2 there. Sorry, Kimberly. Try to draw that better. There's another normal force pair. And again, I didn't give enough information to know exactly which way it's going, but it's somewhere. If I've got a pulley here and I have a rope that touches it, the direction of the force has to be somewhere between the two edges of the contact. So it's going to be somewhere in that direction. Call it y sub r and y sub r. All right, so normal force done. No other. All right, tension. Louder, please.
The tension is on the pole, is it not?
it's on the rope.
Not officially on the pulley. Okay, it is on the box.
Ends of the rope.
Okay. So which way on this end of the rope?
Down to the right.
Okay. So tension, and then opposite on box 2. What about over there?
This way from the box, and this way.
Is that what you were saying, or the other way? That way? Okay.
But it's wrong.
All right, and there's only one rope. We took care of both ends, so tension's done. All right, friction.
I was going back to tension, so if it's like the same, Since it's from both ends, you don't have to do like FQ1 or FQ2.
Right, for the same ideal rope, you don't.
Okay.
If we threw friction into it, it's no longer ideal, or gave it a mass, it's no longer ideal, in which case you would need to do that, but at least through test one, you don't need, a single rope is gonna be ideal.
Box one, friction is gonna go this way, the box wants to go that way. Or,
The friction would go down.
So you said box one wants to go that way, and you said box one wants to go that way.
Yeah, because I mean, if you cut it, it's gonna go down.
Box one wants to
That
go
would've-
that way, but the friction's going that way. Opposing it.
All right,
Is that right?
which way the boxes are gonna go depends on information I haven't given you. It was a trick question on purpose. Which way this thing is going to slide depends upon the masses of these two boxes, and consequently the weight, and the angle. And I did not give you either of that. I did not tell you which is a greater mass. I didn't tell you which angle is bigger. You do not have enough information to know. Again, the more advanced math versions of physics, you could calculate it, but that is beyond the scope of this. So I would have to tell you. So if I gave you a problem like this and I did not tell you, that's the kind of thing, I'm hoping someone would recognize it and come up and ask. Say, wait a second, aren't you supposed to tell us which way it's moving? There was one test I gave years ago, quiz I gave years ago. Almost everyone had finished and they had left because when they were done they could go. And a student comes up and says, this problem's not possible to solve. I said, yes it is. And then I said, well, wait, hold on. I gave them an impossible problem. Unfortunately, most of the people had left by the time it had been pointed out to me. So if there is a mistake, pointing it out sooner than later would be appreciated. All right, so on this one right here, let's just assume that it's going to move in that direction. So which way is the friction acting on one now? All right, I saw several hand gestures for it. Yep. And then up on the ramp. And which way will friction act on two? It depends on what you mean by that, but I think what the spirit of what you said. And yeah, that is all crammed together there. I apologize for that. Not giving yourself enough space is one of the rookie mistakes. All right, now a test level problem, and then we will call it a day. Lab will officially be over. Questions on this before I draw up men pulling sled with sun on it? If you want it to be mother instead of dad, fine. Daughter instead of son, that's fine. Just when I did this, first time I did this, I just had a boy at the time. Oops. As with any parent, he lost all of his identity as soon as his child was born. Okay. This is a test level problem. The way it would be presented, I would set up the situation. I do need to give one other piece of information here, and that fact that they are accelerating in that direction. Imagine that they're just starting out and the dad is just starting to move and they're moving, getting faster going in that direction. Then the wording will be, draw the force diagram on the objects on the next page. Because then I give you all the objects and I spread it out. Occasionally, some will try to do the force diagram on this where everything is touching each other as opposed to on where they are separated. All right. This is now separated into the 5 objects. So you don't have to worry about what's included with what. Put it for checklist. And let's do friction last because friction gets tricky here. Give me a force, direction, object,
Weight
acting,
from the kid onto the sled.
from the kid onto the sled.
Yeah.
Not the way it was worded.
Sorry.
You might draw it correctly, but did you want to draw it?
Did I want to draw where it?
Yeah.
Okay.
I didn't know if you were feeling confident enough to do that. Or will they take a chance?
If it's not, please ignore me.
I did this once with a class where everybody had to come up and draw something on the board. It ended with a student in tears. That's why I always shy about doing that.
Do I put boy, like B?
Yeah, that works.
Is that wrong?
I probably would not draw that fancy, but that works for me.
Sorry,
No, that's fine.
Okay.
There's another one. You want to write the other one down while you're here?
Okay.
They come in pairs. There was the other part of that pair.
Where's the other? Okay. Can I look at my notes real quick?
Sure.
Does it matter what you put next to the W? Or-
What subscript to use?
Yeah.
Not really, just so long as the pairs have the same subscript and it's different than the others.
No, okay, okay, ignore me. Don't.
Somebody just said it. Ground.
The ground?
It's up on the ground. The gravitational force, weight, is between the planet
Oh,
and the
yeah,
person.
just like the boxes. So I can like right there.
Yeah, up on the ground. And same subscript,
What for?
B.
B. Because that's the force that the boy is exerting on the ground. All right. Thank you for being brave enough to do that. I'll open up, everyone else, you can either tell me verbally or come up and draw it. Take your moment to shine. Let the international audience see you.
Okay.
In multiple colors in case you just want to get fancy. All right, there we go, there's another one.
The sled in the ground,
Wait, what in the ground?
the sled,
Okay. So we have three different types of W's there, they all look close enough.
Then there's also a normal force on all of those objects. Dad on the ground,
Would
son
you-
on the sled, and then the sled on the ground.
Okay, so which way is the arrow going on Dad?
Up.
I guess you're using subscript M there.
And then that's down on the ground.
By the way, when Tana drew this down here, it's not actually touching the dad, but it's something like this, it's clearly right next to the dad. This is not no man's land. If she had drawn it over here or in between them, then that's a different issue. But if it's obviously close to one, I go with what I believe you were saying. All right, so I got that pair right there. What about boy and sled?
Up on the boy, and then down on the sled. And then up on the sled and down on the ground.
And if you've ever seen a sled going along snow and you see tracks left behind, it's that normal force right there that's pushing down, causing those tracks. All right, so we've done weight and we've done normal force.
so is the weight and the normal force always opposite of each other?
No. In the case where we had box on ramp, the weight was down, but the normal force was up.
Okay.
Thank you for asking. I hope other people who might make that mistake caught that, because that is a common mistake.
Can you repeat what she said?
Lavina, do you want to repeat what you asked?
I said is the, weight and the normal force always opposite of each other?
And the answer is no. All right. We got three other letters that we haven't touched yet. And again, friction last.
There is no other, is there?
All right, done. Okay. And now we have, yeah, which way is tension acting?
Oh, between the rope and the man's
Away
hand.
from the ground.
Away from the dad. Which way is it acting? When you say away from the dad, which way is it acting?
Left.
All right. I heard left, and then I have,
I'm in on the road.
The dad's pointed
That's
right,
going this way.
and then on the road would be left, right?
so you're talking,
No, I mean towards each other on the road.
okay. Yeah. So it is parallel to what's being pulled, so there is a tension here and then tension there. For the students who recognize that there is a tension there, the biggest mistake, I'm going to erase this and draw up a wrong answer, then I'm going to erase it and put this back up again. I have seen too many times where they got it like this and they pointed like that. Yes, there's a connection between him and the rope, but that is not the way the force is pulling on the dad. This is just a representation of the dad where I can draw my arrows. Attention and attention. And there's obviously another end of the rope, so there's got to be another pair.
Between the sled and the rope.
And which way acting on sled?
Uh,
Okay, go with Jenna Lisa's hand gesture. Now, if I were doing this all in one color, like students generally do on a test, because they have just whatever color they're using, this gets all jumbled up in here. Try not to make that big of a mess. Separate it a little bit better. You know, I think a fair effort to try to figure out what you are intending. All right, tension's done, because we had one rope, we dealt with both ends, and now friction. Probably the simplest, sled and ground. Which way is that friction acting on the sled?
To the left.
Okay, saw a number of people as well as the verbal. So friction, oh, we can go first. The typical stunning effects. Friction on sled, and the other part of that,
Friction on ground.
all right. Let's do dad next. Which way is friction acting on the dad?
Is there friction when you're stepping?
I hope so. Have you ever walked on ice?
It's like different than sliding.
Friction is what helps you. You basically need friction to walk.
Okay.
Oh,
There.
oh, I said otherwise you slip everywhere.
Yeah. So which way, so I heard several people say friction is acting that way on the dad. All right, let me give you a hint here. There must be some force in the direction, or at least part of a force in the direction of acceleration. An equation that Aiden mentioned earlier, F equals ma, which we'll get into later, but the force acting, the total force has to be in the direction of acceleration.
Because he's stepping off the ground, pushing off the ground.
You push off the ground. The dad is accelerating that way, and so the general thinking process that I've seen in the past is the dad's going that way, friction opposes it, so friction's going that way. But what part of the dad is actually touching the ground? So see, dad's going that way. So as he's pushing forward, think about the paper. I've got friction between my foot and the paper. As he's pushing forward,